Show you how to use this virtual lab so we can try to figure out the identity or the molar mass of this unknown acid. Okay, so let's start off with preparing the unknown acid. Give yourself some distilled water, and then you need to get yourself the acid. Doesn't say how much to dissolve. I've done this a couple times, and 5 grams seems like a good amount to dissolve, so we're just going to put 5 grams in there. And now we have our weak acid solution. I made a little spreadsheet, which I'm just gonna show you, and I'll find a way to put in the document too that looks like this, so I can just keep track of the titration that I'm about to do. So this is gonna be the volume of base we're gonna add in a second, the pH of the solution as we add base. Initial mass is 5 grams, you're gonna need to know that, and I also recorded the initial solution volume, and that is 102.58, so let's write that down. Okay, now let's start our titration. So for that, this is kind of annoying. You have a virtual lab space for whatever reason, so we gotta remove some things. So let's add some phenolphthalein. Let's add our base, and we also need our burette, which is found under glassware, other. There it is. Okay, so let's add some base to our burette. I'm gonna add 52 mils, and I'll show you why in a second. That brings our burette up to the 0 mark, so whatever base we add, it's going to be from 0, so we'll be easily able to determine how much base we're adding. Let's get that out of the way, and then you actually don't need this indicator for the way that I solve this, but you'll still be able to see when it reaches that end point, so we'll put in the indicator anyway. Okay, so now we're going to start to titrate. So the thing you want to make sure is that before we titrate, you need to make sure to record the initial pH of the acid, 1.66. I'm going to go to my spreadsheet, and I'm going to put in 1.66 with 0 mils of base added. So this is volume, this is 1, 2, this is 1 mil, 2 mils, and then we're just going to develop a titration curve from that. So let's start to do this now. So we got to make sure you add the burette to the acid, not the other way around, and then you're going to add 1 mil at a time. And as you add mils, you can see that your pH is changing. So it'd be super slow. What I recommend is have one person doing the recording end of it. So whoever's sharing their screen, you can do the titration on a second screen. This screen doesn't have to be shared. The other person's going to record the titration values. So I'll do it. You can see how slow this is if I do it one by one. All right, 1.76, and then so on and so forth. So ideally, you're going to keep on recording. I'm just going to go a little bit because I want you to see that as you add, you're going to enter into that buffer zone. So notice, look at these pH changes as I'm adding this 1 mil. They're not changing all that much. I need to keep on adding to get to the buffer zone. Again, you're going to be recording each one of these mil additions in that data table. But I just want to show you what this looks like as we go through it. So you can take a look at that pH change. I'm just adding a mil at a time. We're still in that buffer zone. We can see that the pH is very resistant to the base being added, even though it's a strong base. As we start to leave the buffer zone, which we still haven't quite yet, this weak acid was on the stronger side of weak acid, so it takes a lot of base to get there. Hold on, let's see. Okay, so now we're still pretty much in the heart of that buffer zone. I'm just noting that that pH change was about 0.15, so but we're about out of it. That pH change is about 0.2, so we're leaving that buffer zone. That was about 0.3, and then we're going to see up, and then we see a big jump. We see that big jump, then our solution changed color. Okay, so you're going to be recording every one of those, so that you can. Let me show you a spreadsheet that I made with all of this recorded. This is a different one. So this took. And you can always add more. So this took 33 mils. I recorded the pH at each point, and then you can see that you can start to look at this. Here's the pH curve. So all I did for this was I just graphed this really quickly. I don't even care about the axes, but I have volume of base versus pH, so I have my titration curve. And from this is what you're going to use to determine the pKa. And I don't want to say too much more. I'll give you hints eventually, but just go back to that lesson on titration to think about how you might get the pKa. Once you determine the pKa, I'm going to go back here. Once you to get both the grams and the pKa, I would just do the pKa first so you know you got it right. So if you have the right pKa, it'll tell you right pKa, but you have the wrong molar mass. That's okay. Once you get the right pKa, then you know you can go further steps to get the molar mass. This is how I did it. There's probably multiple ways to do it. But anyway, it was really helpful for me to know if I got the right pKa. Regardless, keep on, when you think you have the right answer, even put it in here. If it might be slightly off, just keep on going. After 3 tries, it'll tell you what it is. So if you thought the pKa you definitely want to get right, but if you got the grams per mole as like 155 and it ended up being 152, that's close enough, right? So don't worry about getting the exact amount. If you're in the ballpark, then you've probably done the right thing.